So now let's try to have a look and find out whether there are gender differences between test scores. For this, let's insert a pivot table. So ideally with the pivot table, as I told you before, you first think and then you do. And let's say we want to have, let's imagine what we want to have. We have males and females, and we would like to have a score here, a mean, and a mean here. And this is what we're going to compare. So these two values. And we can start simple by doing that. So we throw in our math score here. Let's start with the math score. And let's include gender in the columns. And since we're at it, let's delete all the grand totals and make sure we actually have a meaningful score. Therefore, add the mean and make it also look nicer by only having 2 or even 1 value after the comma. So that we have already, but we remember that the statistical test is actually comparing all the numbers and not just the means. The means is what is the output and the output that we see. So that's also a good reason why we had these IDs here, because if we drag them now, we have all the female values here and all the male values starting somewhere later. Here they are. So now the males scores are here and the female scores are empty, and this is good that it's represented like this because it reminds you that these are two separate groups. So that's exactly the point where the data structure is different. These are two separate groups, males and females, can't be both, at least not in our data set, and this is something to remember. So now let's keep everything in order and shuffle it a little bit and then do the statistical testing. So we say it's independent t-test pivot. We go to our data tab and we are doing 2 samples, independent sample t-test, so 2 samples, and we assume equal variances. We already clicked at this button before. This is when samples, when the groups are very different of size. So if we had only 10-20% of females and 90-80% of males, that would be also the test to use. But now we have more or less the same size. We'll see in a second. If not, we can always roll back. Otherwise, we assume equal variances. This is one of the assumptions. We'll not go very deeply or almost not at all into the assumptions in this course. We're working with big data sets, and when we have a lot of respondents, all the assumptions usually, or most of the assumptions, are usually satisfied by default. And that rolls back into the central limit theorem that you might have read in your literature reading. If you skipped it, that's also totally fine. Just remember, big samples, we can do whatever we like, assumptions are contained. So let's do some testing. We click OK. And we roll back up. So here are our females, and I'm using a shortcut of Shift, Control, and arrow down. And see females ended, so that's it. Let's plug them into the first column. And starting males is variable 2. We don't have any labels now, so just click OK, and we have another spreadsheet. Let's have a look whether there's a difference. Let's brush up a little bit, so all the values, let's have them nicely presented. So these ones, let's tell Excel that those are numbers and have one variable after comma. And where is our p-value? Here it is. And for the p-value, we want also a number and 3 numbers after comma. So highly significant difference we have, and it looks like pretty much the same mean that we had before in a pivot table, and these were males and these were female. So it looks like there is a significant difference in math scores between males and females, and it looks like males are performing significantly better. So what should we remember here? So this is a lyrical note, stepping away from the statistics and going closer to critical thinking. There is a common belief that males are better at math than females. There's a bunch of research on this, and actually the truth is that both genders perform equally good or equally bad at math. The difference is that there is a bit of a stigma, there are some prejudice, and the truth is that we're influenced by this prejudice. So if somebody tells you, or it don't even tell you, and you just know that there is a certain belief about you, you might actually choke, and that's why I perform worse, is the belief is the worst performance. And this is called stereotype threat. So it could be that females are threatened, and the idea that they're not so good at math is salient, and therefore they're performing worse. And there's actually research about that. That's one explanation, and this is the one that they have proven. Of course, there are multiple others. I do not remember where I took this data. This is real data from the internet. There are a bunch of databases where you can download all kinds of data and play around with it and practice. So this is real data. These are real students, and it could be that maybe the females were not too motivated. Maybe the teacher had some prerequisites about it. It could be a different thing. It could be their personal opinion. Then, well, okay, maybe they're not so interested in it because there's a general social stigma. So this is another explanation to it. So I don't know what is the reason behind these numbers in the data, but there is an additional research that tells us that this result, even though this difference is significant, and even though in our sample males perform significantly better, that actually in reality both males and females are usually equally talented or equally not talented in mathematics. Now we're rolling back to the statistics, equal or unequal variances. So we see now the sample size. We have 518 women and 482 males in our sample. So this is more or less the same size, right? It's definitely not 20% versus 80%. It looks quite okay. So we can use an independent sample t-test with equal variances assumed. So now let's rename this to keep it neatly. And let's see whether there is a difference between gender in some other test score. Let's throw the math in and let's do a reading score. So same story as before. We use our data analysis button, unequal variances, and we check whether the sample is the same, or ideally just remove everything and select the fields again. Looks about the same, but we want to be safe. Click OK, and let's have a look what's happening here. Now we are looking at the reading scores, so let's name them before we forget. And first we have here females, and here we have males, brushing up the numbers and extracting our p-value. So here the situation looks different. Females seem to perform significantly better on reading scores than males. I did not look into this research about reading and differences between gender because that's usually not where the social stigma revolving around. It could be that those are also random, or those maybe not random but specific to the nature of the sample. This is something that we should also think about. Maybe the literature teacher is providing only romance novels and those are interested to adolescent females, or the other way around. So that also could be something stigmatized. So depend on the teacher, depend on the area, or multitude of other factors. So here we first of all learned how to compare the mean differences between two groups, independent groups. In our sample, we only have either strictly females or strictly males, and put a significance number on it so that we know whether the differences we observe are actually significant or not. And another important takeaway is that even if you see that the number shows something, question it. And remember, if the number shows something that you actually genuinely believe in yourself, try to put yourself in somebody else's shoes and remember that somebody else might not believe the same thing. Try to suggest a counter argument just to validate whether your data is reliable or not. We always are very tempted to accept if we see the data that is in line with our beliefs, we're more likely to accept it. That's why maybe here I started questioning things because that is not in line with my identity. And here I didn't even bother to look at the research to validate whether this in general sample of general population is truthful or not. So that's minus points for me, but generally remember to question the data. Data is important, it supports our decision, but we need to question it and to cross-validate and to be sure that the data shows what we think it shows.